Today's meter video demonstration is going to be on the Westinghouse Polyphase Watthour meter, Type C Polyphase, or three-phase meter. This particular unit was manufactured by Canadian Westinghouse Company Limited in Hamilton, Ontario, Canada. Now, this particular type of meter was manufactured between 1906 and 1911. This one I have hooked up for the purposes of a demonstration, even though I do not have three-phase to hook it up as it would be in its former days of service. However, when you're testing a three-phase meter on single phase, you wire all the current coils in series and energize the potential coils. Now, as you can see, it has a large pointer hand for tenths of a kilowatt hour. Now, this particular meter is rated at 800 to 5 amps for use with instrumentation or current transformers. Also, the original service it was hooked up to would have had potential or voltage transformers to step, in those days, 2000 volts AC down to 100 volts for the purposes of energizing the potential coils in the meter. It was quite obviously 2000 volts you could not contain in a meter that small, because the thing would just simply arc and blow up. Anyway, the way that I have this hooked up for the purposes of the demonstration, I'm using a 1300 watt incandescent lamp load, which I've used in my previous meter demonstrations, and this time, instead of having a completely cluttered background, I built a bit of a test stand for the purposes of doing these demonstrations. Now, I've previously taken the cover screws out of this meter. Actually, all the Polyphase meter is 2 or more meters in one package with a common disc. Now, these early meters had 2 separate discs. In the case of this one, both discs are mounted to a common shaft. However, some of the very early ones actually had 2 separate discs that each one was coupled into the register by a very intricate system of gears. And I have some of those type as well, which I will do in a demonstration of at some point in the future. Now, I've previously taken the cover screws out of this meter so that I can easily get the cover off of it so that we can examine the insides. Now, I'm going to put the camera in a little closer so that you can see the shaking. You can probably see the true disc turning in through the front of the meter. They're turning so fast that you can't see the black indicator mark going by the front, because this meter is quite severely overloaded. It's rated at 5 amps and I'm pulling it almost 15 through it, and that is an overload. But it's done deliberately for the purpose of a demonstration. For a short period of time, it's not going to hurt the thing too much. And if you notice, the large hand on the front is advancing. You can probably, if I leave the camera onto it for a minute or so, you can actually see it. It's approaching 1 now, the indicator hand. You know, these particular meters were originally mounted with studs through the back, in through a large and very thick and very heavy slate switch panel that would have had open bladed knife switches and bus bars, ammeters, voltmeters, and distribution, fusing, and the like. but I'm not going to get into all of that at the present time. I'm just going to take a moment here and I'll leave the camera trained on that meter so that you can actually see that pointer moving. That indicates that it's got a fairly hefty load running through it when you can actually see the thing move. And again, being a 5 amp meter, it will move quite quickly, especially when it's got that much overload on it. The things, a 5 amp meter would usually handle 10 amps without burning out. Anything over 10 amps for an extended period of time, and the insulation on the windings in the current coil of these things is going to start to burn. And I even have one meter in my collection where the current coils are completely burned out of it. All insulation is gone, and it's just a stack of bare wires sitting there. Funny part of it is the thing still works, but it would be completely inaccurate. Anyway, I'm going to just take a screwdriver and assist the metal cover in coming off, or I think it'll come off. Okay, excuse my clumsy attempt at trying to get that cover off. It didn't want to come off too easily because of the mess of wires that are around the bottom of it. Now, these old things would have originally had wires that come through holes in the slate backboard, and they were fastened on with these thumb screws around the outside perimeter. Now, if I move the meter, or I won't move the meter, I'll move the camera. And if I move the camera over, okay, now we've got the camera moved over. Sort of a shaky move, but I don't have fancy camera dollies or anything else to move around, so I'm just using a tripod and a fairly cheap pocket-sized digital camera, which I'm using in movie mode. Now, what you're seeing here is one disc, and this is the second disc up here. Now there's a set of braking and retarding magnets which regulate the speed. If you move a magnet in closer towards the center shaft, then the meter is going to go faster. And if you move it out closer to the edge of front edge of a disc, that's going to retard or slow it down. So there are various adjustments on the meter that you can regulate this, but you have to use pretty straightforward voltage and current control. Now I'm going to move the camera. Now we're looking at the right hand side of the meter. These meters had a real block of iron in the things. They would withstand, you never had to worry about them overheating. The later later modern meters used way smaller amounts of iron, way smaller wire, which was wound very tight, and either voltage surges caused by lightning or any sort of a thing that caused the power to fluctuate suddenly could cause those newer ones to go open. Although I don't think I've ever seen one of these old meters in the many hundreds of the things I've examined since the late 1950s that ever had a burnt out voltage or potential coil. I've seen lots of them with burnt out current coils, but never the voltage coil. Anyway, there's not a whole much more I can say about this particular type of meter. It's one type that I've had for over 25 years, and this past week I just recently fell heir to a twin, so I now have a pair of the things. And anyway, the thumb nuts for the connections are missing off the one that I picked up this week. So anyway, this is the one that I picked up this week, and the thumb nuts are off the one I've had for quite some time. Now, on my other meter, the paint on the dial on the register is all crazing, and the enamel's starting to lift off the metal. So what I will be doing with that will be taking the cover off and giving it a very thick coating of Krylon clear plastic spray over the entire faceplate, so that it stabilizes the stuff so it doesn't crack off, because the meter will actually be ruined if the legends come off the face of it. Anyway, that's about all I can say for the Westinghouse Type C Polyphase at this time. I'll just turn the camera around again so that you can see my 1300 watt incandescent lamp load. The lamp on the left is 1000 watts and the one on the right is 300 watts. I've since found another 1000 watt lamp which I could use as a 2 kilowatt load. However, I'd be up more than what the 15 amp circuit breaker would handle, and she'd trip off. So anyway, back to the meter, and as you can see, the hand is advanced down just halfway between 3 and 4. So she is moving around, no question. So that's it for the Westinghouse Type C Polyphase, and hope you enjoyed this demonstration. Thank you very much.